Okay, so lots to go through. So design for facilities management, as we were just discussing. So why we do it? So I like to give this example a lot. Uh, let's say like this lighting fixture, we have planned to install it, and it has 25 years of life expectancy. And in the traditional manner, your FMO people will figure it out when it is going to expire through the documents, Excel, however. But with the data that we are gathering, they will have an opportunity to feed this information in the FMO system, that is facilities management and operation system, and that FMO system will give you a nudge at 24 years. It's like, hey, you have 1 year to go for this live fixture to be expired or at the end of the life expectancy. So start your procurement process, hire a consultant, get the bid, and start rolling on with the installation and replacement. So that's something if you want to do, that's where you need the additional level of the facilities management requirement on a project. Unless like you're just going to build something and giving it away, then maybe not. But if you're going to own it, this is where you want it. And especially on a hospital project where you're running a building 24/7 for so many years and decades, you need something that is 100% working and you cannot just get away with doing the bare minimum. So let's just run through the basic things. So for example, this is the information chart that is required for a blanket format like that. That's not the blanket format we are using. It's just a limited image I found online. But the tag ID that you see here is how that blanket format is identified. And if something is wrong with that, the FMO team can just like, okay, this is the tag, go and fix that. And that will tell you that's the facility name, that's the level, blanket format, what's the other information over there. But we need to, from the design team, we need so much more information to just identify one little element. And yes, like even looking at the tag, that's me. Like, is that the blanket format? And we have, just in the architectural scope, we have 62 identified tracked asset. And the idea behind that identified tracked asset is that we have hundreds or thousands of assets in the building. Not every single thing needs to be tracked. So during the pursuit phase and the design phase, we had this conversation with the client back and forth to figure out what's required for the facilities management, where the value lies, because each one of that added item is tens and hundreds of hours. So like across that 62 identified tracked asset, we have 5,000 plus unique instances in just VGF scope. And there will be much more in parking because they have much bigger clinical scope. So identifying the scope gap is important. And the best thing that we did was early on, we identify what's required, identify the only class for it. So everybody's on the same page. We cannot just call it a blanket format and five people are looking for five different definitions. So we use this omni class as a baseline that, okay, whatever they say, we will use that. And from that, once that is identified, what level of information is required at each one of this phase? So blanket format, it requires serial number, it requires installation date, what's the expiry, but not every single tracked asset requires all that infinite amount of information. So you need to identify in different categories. So we had 4 different categories, the G1 being the highest and G4 being the least amount of but still tracked asset. And from there, we came up with this chart like, yes, this is what we need, this is what we don't need, and going back and forth with it, identify what's it. And that's how it is exported. So when you look at the beautiful Excel, well, I'm an Excel nerd, so I like this kind of information. It's easier for the facilities management software to read, but not so much for human. So for example, if I get this information to Pat, like, all right, Pat, so you need to get this information from the vendors and the trade partners and feed that the serial number and the date of installation, so on in this Excel, he's gonna probably go crazy, if not already. I'm not answering it properly. So we had another intermediary tool for us to work with. So that was the Durofus. And we needed that for the room data management. So Jen, let's talk about room data.
All right. So as you probably have heard, like this project is very complex and very big. So given that, the team has decided to use a database management tool. So we chose Durofus as our data management tool. So for this presentation, I'll quickly go through what's Durofus, why we use it, and how we use Durofus.
Single click.
Right. So what is the Rufus? I'll just go through them. Why there's so many? Okay, you probably are familiar with what the Rufus is. So either you like it or hate it, but it is working for us. So the Rufus is a cloud-based data management tool. We went and go back a little bit. A cloud-based data management tool. So basically, all your data is in this cloud format. And what's beneficial for using the Rufus is that bidirectional synchronization between your model and what's in the Rufus. So basically, they talk to each other. So you don't have that one information is in one format and the other information is in Revit, so they don't really talk to each other. The Rufus bridges that gap. And along with that, all the stakeholders are able to access that database. So you access the same information in just one area. So why do we use it for this project? So just a few stats here. This project has like 40 plus departments, 4,400 rooms, 6,600 plus unique items across, FF&E, accessories, amenity, etc. You have 280,000 plus item instances. I said you're an Excel nerd, so I'll give you an Excel. So this is how we did it before. So without using the Rufus, this is a sample of our previous project. We used to do everything in Excel. So, this is a sample, one department, you have all the room finishes there. This is just for room finishes. Now imagine multiplying that across 40 departments and doing that for all the other items as well. So it's a lot of Excel. Chit will be happy. There's a lot of Excel going on, right? Now, the problem with Excel is they don't talk to Revit. Like you can push information to Revit, but there's limited ways of checking what's in Revit and what's in your Excel. So that was a big challenge for us. So how we use the Rufus in this project. So these are just a few examples. There's a lot more. So room data and history tracking. So once we receive the statement of requirements from the client, we bring into the Rufus. We put in all the information needed for that room. We then use the Rufus to create the rooms for us in Revit. So we're not doing it manually in Revit. We're just getting the information from the Rufus, pushing it into Revit. So you have that one single source of information. We're able to track and record some room design progressions. Like if we split rooms, we delete rooms, we're able to keep it in the Rufus. We're able to track why it was deleted, why it was split. We're able to manage room finishes. So room finishes information is directly linked to Revit. You have that 1:1, right? So one room in the Rufus, one room in Revit, they talk to each other. You can push and pull information. Consistency of information, we use templates to make sure that the rooms stay consistent. So let's say you have 100 patient rooms, all the finishes are the same. You use just one template, right? So for all of them. If you want to update a certain information for those rooms, you just update the templates. You don't need to go through each and every room. So that helps with the updating and maintenance of the finish information. And lastly, managing and tracking of FF&E. Eliston has been always updating the Rufus equipment list. They have the ability to upload the data cut sheets directly to the items. This feature, our family creation team really likes this feature because you're able to just go through the item, pick it up, push a button, and you have your cut sheet there. You don't have to you look at this folder, you look at this file. All of it is in the Rufus, so you're able to see directly what the item. So this was taken from the BIM execution plan. So just a quick summary of the Rufus workflow. It basically shows you the data process, how it goes from within the team, who's included, who's involved in those processes, how the Rufus is used, and then how the QA/QC is done as well. If there are any issues identified, you just go back to the team, check, and then you go through that QA process again. All right. So for the Rufus execution plan, we have sort of an overarching principle of how we're going to use the Rufus. So basically, it's divided into 6 major categories. So for the first one, we tried, for the first one is Rufus first, which is a one-way street. Make sure that the Rufus is sort of your source of truth. But full transparency, there are still some items we do push from Revit to the Rufus. So it's not a perfect system, but we do try to adhere to make sure there's only one source of truth right there. Number 2 is design versus program. We make sure we compare whatever is required and whatever we have in Revit by using the Rufus, so we are able to see those differences. Manage truth templates. We talked about samples of like finishes. We also do this for items, equipment list. The Fed team from ED uses templates to update their equipment list. I'll show you a few slides later. Model viewing and checks, basically it's just the Rufus has this tool called Web Rufus where you're able to see live, what's in the model and what's in the Rufus without having to open a Revit model. Items over data, this one is a new one for us. I'll speak to it a little bit more later, but essentially we're trying to make sure we're comparing apples to apples. I'll give you a few examples later. And last would be the sub items. These are basically if you have items that have parent or child relationship, we make sure to put it as sub items, not as individual items, but they are connected to a sub item. All right, so item over data. So I just want to kind of focus on this one, why we did this principle. Usually when you get the requirements, so you bring in the information in your Revit. So example of this is wall protection, for example. In a room, it says, okay, it may be a check mark or a line item. It says you need corner guards, you need chair rails. That's a line item in room Revit. But when you design, you're not really designing through the room, right? You make use of elements, like you use families to you put a chair rail, you put a guardrail. So there's that disconnect between what room data is and the items in Revit. So what we're trying to achieve here is have that apples to apples comparison where we extracted the requirements as items. And in that way, you're able to compare items to items. So you can clearly see it's the same format now. You don't have to go to a room data or an item data. So that's what kind of our governing principle is there. So another great example of using item over data, the Fed team from ED, they made use of the derived function in the Rufus. So for example, this is on this side, this is the requirement, the original requirement. And on this side, this is governed by a template. And then anything that's derived means it's something new for that item. So for example, this one you can clearly see anything orange is new or either deleted or new for that room. So it's basically a quick comparison or an easy comparison between the two. I just want to show you one of the templates we used, how we use it. This is from the ID team. They created some templates for controlling the room finishes. So I just want to give you an example of that. Also an example from the electrical team. They use the Rufus as well. One thing I want to share, we have we did a coordination with the mechanical team. Basically, they asked us, we have some parameters that we want to see in your family. So it's kind of a big challenge because they want to see it in our family so they can do their calculations. So what we did is that, hey, items are linked to the Rufus items are linked to our families. Just update the Rufus items, we'll push it to our families. So that was a simpler way of doing that coordination instead of like, okay, import this Excel, we'll import back and all of that. stuff. So we didn't need to do that. So like I said, the items, you can upload the cut sheets. So you see here, when you go to the documents, you can clearly see this is the cut sheet, and there's a version 2 there. You can clearly see there's a newer version of the cut sheet. So our team, our family creation team, will know to update the family. Give you a sample there. And lastly, for this project, we are required to produce room data sheets. For those who have used the Rufus, you know, out of the box, the Rufus templates and reports, they're kind of a bit of a challenge to manage and sometimes very challenging to customize. But the team here in ZJF did a great job of creating a custom report for the project. This was taken directly from the Rufus API and arranged it to a more user-friendly, more simple and clean format for the client.
Shan, I think you are up for the asset integration. Asset data integration. So I'll be touching on what we had talked about previously, just touching on the facilities management and everything else. So the first step is what? Populating information in the Revit models. Now, just a context before I go deeper into this is initially it was a big challenge coordinating with different consultants, trades on how to get this information together. And one of the challenge from the architectural team was they could only provide information, I think by AIBC and EGBC, that they could only have information populated for their scope. They cannot have any third-party information in their Revit models. So that was a big challenge. So we brainstormed and came to a solution that the information that we are going to need from the trades, which is your installation date, serial number, manufacturer's name, model number, everything else needs to come from the trades. That is not the responsibility of the architects. So that information, as you can see at the bottom, that comes from the trades. And as Jan mentioned, we use Rufus as the central data register to push that information into Rufus. And then from Rufus, the information was pushed back into Revit. And at the end, this is the final model that you have, wherein the design team has already populated their piece of information, but we are also inputting now with the help of Rufus, the trade information, which is more crucial for the facilities management group, because that talks more about replacement and all those things that they need in terms of like warranties and stuff. So that information comes to that. So this is a big challenge. We've navigated Rufus. So this is kind of the workflow at the handover, right? So you have different design stages on the top. You have the design models. The design team is working in their design model. Rufus is again acting as a central data register. So they are populating their piece of information, their scope of information, and then from the trades, it's coming in towards the end because the trade information comes in at the very end when we are into construction phase. They don't have anything before that, obviously. And then during the construction phase, that data is then populated back. And then the final deliverable is a federated model with all the data that the team needs and complying with the requirements. So that's the handover model. So this is another example of the Kobe spreadsheet that you just generate out of Revit. The challenge here, so we're trying to push the boundaries with this. One deliverable for us is the IFC models. So we are not just exporting the IFC models from here. We are also exporting the data that you see in Revit to IFC. It is not as simple as just exporting. It's a lot more complex process. So this is the first step. Now, how do we get to that stage? So think about this as different. This template here, think about it as a Google translator, right? Revit is one language. IFC is one language. They both don't necessarily speak the same language. There is some overlap, but the overlap is minimum. So
This is, we call it the mapping file. So we basically map some of the Revit parameters to the IFC parameters. And then this is an example of the export setting in Revit. And you have to basically generate the mapping file wherein you say, okay, this parameter in Revit means this in IFC. So that at the end of the day, when someone looks at the IFC model, that information is populated at the correct location, right? So for example, warranties. So warranty parameter in Revit would be named differently than what IFC would be. So that's the whole exercise. It's a big learning curve, and we're still continuing to go and refine our process. But this is something that is going to help the client. And this is the Solibri model checker. So this is what you see in Solibri. So you have all the different parameters. They have the information. This is, you can think about it as the same information that was in Revit, and this is in the IFC. So for someone like Fraser Health Authority or any other client, they would rather have an open source model because they might not purchase Autodesk licenses, they might not work in Revit. For them, they need open source information. Up till now, we were just exporting IFC models, but this is something that we are pushing the boundary and taking this to the next step, is we also need the asset data information. And that's the whole exercise behind this. And this is kind of the final product. So if you open a model, and you can basically go and validate the asset data information.